Hello everyone, welcome to my channel. Today we'll discuss on the topic advantages and limitations of quantum computing, which gives an overview of benefits, challenges and real-world applications of quantum computing. Coming to the introduction of quantum computing, it is an advanced computing technology based on the principles of quantum mechanics, a basic branch of physics that explains the behavior of matter and energy at atomic and subatomic levels. Whereas in classical computers, the data will be processed in terms of bits. So, as we all know, bit can consist of only two values, can be 0 or 1, not both at a time. So, here in quantum computer, the data will be processed in terms of qubits, which is considered to be a major advantage over classical bits. And why is it advantageous over classical computing? Because a qubit can exist in the states like 0, 1 or both 0 and 1 simultaneously, which is called as the principle of superposition. Quantum computers mainly uses two principles, basic two principles which are very important. The first one is a superposition, the other one is entanglement. To have a detailed explanation along with real-time examples, you can refer to another video in my channel related to superposition and entanglement. And due to the presence of these two principles, the quantum computer can solve certain problems much faster than a classical computer. And coming to the advantages of quantum computer, as it uses qubits, the data can be processed very quickly, nothing but a massive computational power, and at the same time parallel processing can be done, which helps in faster optimization, advanced simulations, improved cryptography and AI. And coming to a few of the advantages of parallel computation, which is nothing but as the qubits can exist in multiple states simultaneously, quantum computers evaluate many possibilities together. This happens because of the principle called as superposition. So, quantum computers use the superposition to process multiple inputs simultaneously. Instead of checking one solution after another, quantum systems analyze many solutions together. This is also called as quantum parallelism. So the main idea in terms of mathematical is for n qubits, the possibility is 2 power n states that can exist simultaneously. For example, if there are 2 qubits, the possibility will be 4 states. If it is 3 qubits, the possibility will be 8 states. In the same way, if it is 10 qubits, I mean the input is 10 qubits, the possible number of states will be 1024 states. So this grows exponentially. And mainly this parallel computation is applied in database search optimization along with route optimization, traffic management, financial prediction, etc. And the next advantage is artificial intelligence and machine learning. AI requires huge data sets, optimization, and pattern recognition. So to improve all these things, computer will be helping a lot. Quantum computing improves training speed, decision making, feature optimization, etc. And the major applications are speech recognition, image processing, autonomous vehicles, recommendation systems, etc. The another main advantage is the cybersecurity. So, coming to cybersecurity, the main major field in quantum computing is quantum cryptography. So, the quantum cryptography is considered to be a very major field in quantum computation because the data should be exchanged among two parties or multiple parties in a very safe mode. That is, the secure data transmission is very much necessary in field of cybersecurity. So for the data to transfer in a secure way, this quantum cryptography supports a lot, because of which it enables highly secure communication systems. So quantum cryptography uses quantum key distribution. So any hacking attempt changes the quantum state. So the main principle behind this secure communication is one of the quantum principles, nothing but the entanglement. So because of this, any unauthorized access becomes detectable. So this is applied in banking security, military communication, government systems, etc. So here comes the limitations of quantum computing. Like mentioned, they are high hardware complexity, decoherence problems, noise and error sensitivity, expensive infrastructure, limited practical availability. Despite of many advantages, quantum computing still faces some of the major challenges. It can be considered as disadvantages, but they can be considered as major challenges in which the research is happening in terms of these limitations to overcome these limitations. Among that, the first limitation can be considered as the decoherence. So mainly decoherence means loss of quantum information due to environmental interaction. As we know, the quantum machine is very sensitive and it is placed in within the coolest climatic temperature. And any noise or any external disturbance is caused once the data is being processed, the quantum state of the qubit is lost, because of which the functionality totally it stops. So this is considered to be a major limitation. So qubits which we use in quantum computation are extremely delicate. So any small disturbances as discussed, such as heat, magnetic fields, vibrations, can destroy quantum states. So decoherence means loss of quantum information due to environmental interaction. So why is it considered as a problem? Because of this limitation, the calculations may become incorrect and the quantum information is lost. So quantum states are very difficult to maintain. Coming to the next limitation, noise and error sensitivity. Quantum computers are extremely sensitive as we discussed earlier, and any small disturbance also can introduce computational errors. So quantum computers are sensitive to external interference, radiation, temperature fluctuations, etc. So it can create computational errors. So classical computers can easily correct errors, whereas in quantum systems, it cannot directly copy qubits because of the no copy or no cloning theorem. So quantum error correction is very difficult. Next, coming to the cost and infrastructure. As mentioned here, the quantum machine and all the hardware that is related to a quantum computer extremely is very expensive, and it requires extremely low temperature. It needs sophisticated cooling systems and very expensive to build. And coming to the another limitation called as limited applications. It is not suitable for all computational tasks, and classical computers are still better for many everyday applications, and quantum advantage exists only for specific problems. And there are very few algorithms in quantum computation, so a lot of research is happening in discovery or invention of new algorithms. So these can be taken as a research area to as a part of the research. And one more thing is the quantum computers are very expensive, so the normal people cannot have a daily view, or they can't work with the help of a quantum computer as a part of their daily routine. Whereas classical computers are still better because the normal people like us, we will not use, we might not need quantum computers, because the tasks which we are doing are can be solved with the help of a classical computer. Mainly, the quantum advantage comes in terms of drug discovery, as we discussed the most of the examples. So here comes the real world examples: the drug discovery, financial modeling, weather forecasting, logistics optimization, cryptography, and cybersecurity. So, drug discovery along with DNA analysis in terms of finance, it can be in portfolio optimization and fraud detection, whereas in weather forecasting, getting the appropriate forecasting results, and in terms of transportation, and in terms of security, especially in terms of transportation, it can be route optimization, and in terms of cyber security, as we discussed earlier, in for quantum key distribution, which provides a very secure communication. And finally, coming to the conclusion, quantum computing offers enormous computational power, whereas it can revolutionize science and technology. However, several technical challenges still exist, but still those are the challenges not considered to be a disadvantage, and the future advancements may overcome current limitations as the research work is already going on. Thank you for watching and listening to the video.